We'll have to factor the denominator. And we know from last time we refreshed our memory on 3 special products. And as I promised, I will not recycle this. So it's this formula. It's the difference of squares. Please remember, a plus b times a minus b. So can anyone give us the factored form of this expression, x squared minus 144? Anyone? Anyone?
It's plus 12 in parentheses and then x minus 12.
Very good, awesome. So therefore, you're going to give me 2 restrictions for this variable. Which restrictions? Which numbers will not be ever accepted?
Positive and negative 12.
Great job. Thank you very much. Like before, I will move. What is left on the other side? Extremely important, not to forget. Very good. The least common denominator.
Wait, you said the least common denominator?
Yes. I have to find the least common denominator because the denominators do not have the same denominator. I cannot add or subtract fractions that do not have the least common denominator. Least common denominator. Can anyone give us the least common denominator? I couldn't hear. Anyone? I'm sure you know what the least common denominator is, right? Please say so if you don't.
X plus 12 times x minus 12.
Very good. Same idea. X plus 12 was already there. X minus 12 was not. So we have to multiply the numerator as well. X minus 12 was there, but x plus 12 was not. So we have to multiply the numerator as well. This is the same. No changes needed. If you feel comfortable, you can put 1. So 3 has to be distributed, and I have minus 36. Negative 2 has to be distributed, and I get negative 2x minus 24. And then minus 5x. Are we okay with this step, everyone? Don't let me move on. If you have questions, please unmute yourselves and ask any question.
Did you cross multiply to get that?
No, cross multiplication is only in a proportion. What I did was I asked myself, I started with x plus 12, but I multiplied, it appears that I multiplied x plus 12 by x minus 12. If I multiply the denominator by x minus 12, I have to multiply the numerator by x minus 12. I started with x minus 12, but I multiplied it by x plus 12, so I have to multiply the numerator by the same. You could say this here, but this is not the cross multiplication rule, so be very careful with that. Next, we combine like terms, so I have negative 7x plus 3x, negative 4x, and negative 36 and minus 24 minus 60 divided by x plus 12, x minus 12 equals 0. Yes, I have 2 options. I would say a fraction is 0 only when the numerator is 0. Negative 4x minus 60 equals 0. I move negative 60, and I divide by negative 4. And I get negative 15.
You don't do anything with the denominator?
Very good question. A fraction is 0 only when the numerator is 0. A fraction is 0 only when the numerator is 0. The only thing that I have to do right now is double check. Is negative 15 on the list of restrictions?
No.
No. Solution. It has to be accepted. It's not on the list of restrictions. Any questions? Let me know if you encounter any difficulties. I hope that this is good enough. If not, we'll go back. Now I would like us to review factoring. Factoring is a big deal. It's, I asked you if you could, or at least save these files. I had two supplements, one which is the factoring supplement, and the other one which is the factoring flow chart. So we're going to talk about these in our endeavor of reviewing factoring. So first of all, factoring is refers normally to polynomials. So when we talk about factoring, we really have in mind polynomials. We can have rational functions, but still in those are polynomials. There are three different situations, and we have to treat them completely differently. One is when we factor binomials. One when we factor trinomials. And the other one when we factor polynomials in general, not two terms, not three terms, but 4 or plus terms. So that's exactly how I have it in my flow chart. This is basically a month of work in the previous classes. I'm going to try to do it with you in half an hour. So that's why you see here binomials, trinomials, and polynomials. They are completely separate. Three different categories, not to be combined or mixed or confused. If it's a binomial, I use a certain strategy. If it's a trinomial, a different strategy. If it's a polynomial, that's the easiest. 4 terms or more in general. So I'm going to start by reviewing binomials, and then trinomials, and then polynomials. Okay, factoring binomials. Binomials are 2 terms. So I'm going to just review with you the 3, actually 4, but one of them is not factorable. So I'll say 4. 4 different special products. These are the 4 special products. So let's start with the first one that we know now by heart. This we know. It's a plus b times a minus b. We discussed that last time. We discussed it differently. We discussed it in this direction, but now we are discussing it in this direction. Here we were multiplying to get this. Here we're factoring to get that. From 2 terms into a product, this is a product, multiplication of 2 factors. The next in line in our list of 4 special products is a squared plus b squared, which is not factorable. And then you can say, why is it there? Well, so we remember this. This is not factorable, but it's not correct 100%. I have to put in parentheses, using integers. We can factor that, but not using integers. Now we have, obviously this was the difference of squares, and this is the sum of squares. Sum of squares. So difference, we wrote that last time, of squares. Sum of squares. But we also have what is called the difference of cubes and the sum of cubes. These are more difficult, but once you understand the pattern, they are all of a sudden very easy. They become very easy. This is the only binomial, the sum of cubes. So this is sum or difference of cubes. This is the only one that factors into a binomial and a trinomial. So, for a moment, let's go back. The difference of squares factors into a product of 2 binomials. The sum of squares is not factorable using integers. All of a sudden, we are looking at the difference and the sum of cubes. Difference and sum of cubes factor into a binomial times a trinomial. So, pay attention to the pattern. It will not be difficult. Initially, you're going to say, oops, how do I remember that? Not difficult if you pay attention, please. So, what do I cube to get a cubed? Well, obviously it has to be a. Only a cubed is a cubed. The difference is always in the binomial as well, transfers to the binomial. If I have the difference of cubes, the binomial has the difference. If I have the sum of the cubes, of course the binomial will have the sum. What do I cube to get b cubed? Obviously b. So far now, no difficulty. I just have to identify the a and b. What follows here is very similar to what we discussed last time. Not exactly, but very similar. Identical, but without the 2. No 2 in there. But which one goes where? So let's establish the sequence of signs. If we have the difference of cubes, the binomial has the difference, and the middle one has positive. If we are factoring the sum of cubes, the binomial has the sum, but of course the middle one will have the minus. And the rest is what I know from before. Without the 2. So this is it. This is all that we need to know about binomials. Now let's practice this. Before we even look at examples, any questions, please? Any questions? Anyone? Any questions? So, first things first, meaning I need to go through these steps before I go through the binomial sequence. I have to make sure that the binomial is in descending order. I have to make sure, or I have to factor the greatest common factor. And I have to also factor the negative leading coefficient, if there is one. So, starting with an example from this handout, I'm going to start with the first one, which is 4z squared minus 25. I will not jump ahead. I will just make sure that I check that it's in descending order. Yes, it is in descending order. Z squared, the term with z squared is first and no z. descending order of the powers of the variable. Yes. Is there a greatest common factor? No. 4 and 25 do not have a common factor, and that's z squared. No. Negative leading coefficient? No. The leading coefficient is 4. There's no negative leading coefficient. So now I identify the fact that this is a binomial, and I'm going to go through the sequence of possibilities. Is this a difference? Yes. If it's a difference, then this and this make no sense. So I have to establish whether one of the difference works. If none works, then it's not factorable, and I'm done. If the difference of squares works, then I will use two binomials to factor. If the difference of cubes works, then I will have to use a binomial and a trinomial. So now which one is it? I'm asking myself, can I find something that I square to get this term? Can I find something that I square to get this term? And if this is a difference of squares, then one of them will have plus and one of them will have minus, and both quantities will be the same. So can anyone tell us if there is a quantity that I square to get 4z squared and a quantity that I square to get 25?
For z and 5.
So this is a 5 indeed, and here?
4z.
But 4z squared.
Oh, 2z.
Very good. Awesome. That's it. That's my answer. Excellent. Great job. So we factored completely. Okay, so let's look at y cubed plus 8. That's another example here. Good. So I go through my sequence of steps. Is it in descending order? Yes. Yes, it's in descending order, y cubed and 8. Greatest common factor? No. Y cubed, 1, and 8, no common factor. Negative leading coefficient? No, it's positive 1. It's not a negative leading coefficient. Okay, so now I identify, is it a binomial? Yes, it's a binomial. And I see it's the sum. So then these two make no sense. This one I know it's not factorable because it's the sum of squares. So I'm going to try this. But like before, I'm going to ask myself, can I find something that I cube to get this term? And can I find something that I cube to get that term? And if it is the difference, the sum of cubes, then I'm expecting a binomial times a trinomial. To establish the sequence of signs, positive, positive, negative. But now the question is, can I find something that I cube to get that? Can I find something that I cube to get this?
Y and 2.
Very good. And that's it. Remember the pattern here. Square, square, product. Without the extra 2. Great job. Good. So let's continue with trinomials. And we can come back to more examples. You'll let me know. When you start working on this homework, I hope you will make side notes and say, I want to ask this question, and we'll do it in class, of course. Now we're talking about trinomials, factoring trinomials. Okay, so here we only have two special products. The ones that we discussed last week. Not last week. For me, it looks already like last week. Just these two. But we discussed them this way. Now we're going to discuss them this way, in factoring. So we have a squared plus 2ab plus b squared that we know from last time is a plus b squared. And I am lazy, I don't want to write it again. And I am going to do this. If I have minus instead of plus, then I have minus instead of plus. So let's choose some examples. Let's say from the same handout, I'm choosing the first one. Y squared plus 121 minus 22y. Okay, nice. I cannot skip steps, and I have to go through all these before I identify which category I'm looking at. Is it in descending order? No. Y squared, y has to follow, and no y has to be the last. So then I rearrange it as y squared minus 22y plus 121. I'm done with the first step. I move on to the second step. Is there greatest common factor? No. 1, negative 22, and 121 do not have a common factor. Is there a negative leading coefficient? No. The leading coefficient is 1. Then I identify, is it a binomial, is it a trinomial, or is it a polynomial? Yes, it is a trinomial. It has 3 terms. So I'm here. I will always try the special products first. Which one? This one with minus, so then this one makes no sense because it has plus in the middle. So I'm trying to see if this works. What happens if it doesn't work? Then I have 2 other options later, but we haven't discussed these options yet. So I see that without looking at the middle term, don't look at the middle term, I see that, like before, the same idea, that this is a perfect square, and I also see that this is a perfect square. What do I square to get y squared?
Y.
Excellent. What do I square to get 121?
11.
Excellent. See, there is a minus here. So my hope is y minus 11 squared. However, this is not enough. This is my hope, but I don't know. Because I only focused on this term and focused on this term. I haven't even looked at the middle term. I don't even know what the middle term is. But I know from last time when we reviewed this, see, I told you that this will pop out all the time. I know from last time that if I have y minus 11, the middle term will be the product of y and 11 times 2. I'm going to check that right this moment. I don't know. I don't want to look. So the middle term here has to be the product of these two, 11y multiplied by 2. Now I look. Is this term that? It is. So now I'll say yes. This is indeed the factored form. It's not sufficient to look at the first and the last and come up with the answer. I still have to check the middle term. Mandatory. Now I'm happy. I know that y squared minus 22y plus 121 can be replaced by y minus 11 squared because they are the same. Next problem, let's say a squared plus 6a plus 9. Any questions? I always wait for your questions even if I don't say it, so please remember that. So a squared plus 6a and plus 9. I diligently go through my steps so I don't forget. If I skip a step, I make my life more difficult. Descending order? Yes. Greatest common factor? No. 1, 6, and 9 do not have a common factor. Negative leading coefficient? No, the leading coefficient is 1. Binomial, trinomial, or polynomial? It's a trinomial. It has 3 terms. I will always try the special product. Now this one, because this one has minus, I'm going to try this one. And I see that this first term is something that I can replace by something squared, and the same thing here. It's a perfect square. What is it? What do I have here and what do I have here?
In 3.
Great job. So what is your hope then? Anyone? Any hope? What do you think? Anyone?
A plus 3.
Excellent. However, we know that that's not good enough. I have not checked the middle term. But I know that the middle term is the product of these two multiplied by 2. So if the middle term is not 6a, this does not equal this. It is 6a. So I'll say yes. This is indeed the factor form. Any questions? So these were nice cases in which special products were applicable. Let's move on. Moving on to the second page of this handout. I'm going to pick the first one, 6y squared minus y minus 1. Sorry, I skipped. Sorry. I still have this first. So let's say I'm going to pick b, x squared minus 20 minus x. Sorry about that. X squared minus 20 minus x. Okay. I go back to my strategy.